All right, we go. So to kind of start off this lecture, we're going to finish up yesterday's lecture. The last 2 days basically been talking about how to take a three-dimensional figure and move it to a two-dimensional plane, or take a two-dimensional figure and put it on a one-dimensional line by just figuring out what the new coordinates would be by using basically just simple algebra once you develop an equation. On number 2, it's still asking that, but it has something happen to it first. So we have this point in space, 3, 4, 0. It's then rotated around a z-axis. So we need to use our rotating or our rotating matrix. I forgot what transformation matrix to help us with our rotation around the z-axis. The issue is when we're rotating, what's missing here? No. We're missing the degree. We actually do not know how much we're rotating. So the follow-up question with this is, at what degree value is the object out of sight on plane y equals 1? Right? So it's got a lot going on here, but I'll show you the main things that you need to know how to do. So it is a pretty good process. So at any point you get lost, please let me know. What it's doing, it's taking those first 17 lessons when we talked about transformations of matrices and blending it with what we just talked about in the last 2 days. Go ahead. No, theta is the degree. Distance is the square root of a squared plus b squared, which is the magnitude with a little absolute value things. Well, theta has always been degrees. All right, you can technically do it in radians, but we've been playing around with degrees. All right, so first thing we need to do is determine what is the 3x3 matrix that would rotate around the z-axis. What do we know is not moving? And which one is the z-axis? The bottom row and the last column. So the third row, third column. So when I build out my matrix here for my transformation, I know that the bottom row or the third row and the third column will not change, right? Now remember this? If not, I think you go to lesson 12 or 13. There's like 18 of them that we wrote out. What goes in the next spots? Not quite, because we don't know the angle. Good, the cosine and sines. Now, again, we don't know the theta, so we must leave it as cosine theta, negative sine theta, sine theta, and cosine theta. Do y'all recall these 3x3 matrices? All right, we did this in the couple of tests ago. But now you're going to take that and now multiply it to this point. We're going to do the rotation first. So we're still good. Now, to refresh on why I'm multiplying like this, remember this is a 3x3 times a 3x1. The inners have to be the same for you to actually multiply. If you tried the other way, you would get 3x1 and a 3x3, and then the inners wouldn't work. So do make sure you do the 3x3 to the 3x1. All right, now since we don't actually have any numbers, we're about to develop some equations that instead of actual numbers. But they would represent a number if you knew what theta was. So here we go. How do I multiply matrices? Row by column. So I'm going to take row 1 and multiply it by column 1. It happens to be the only column, so it's quick and easy here. So cosine theta times 3 would be what? Typically, we write it as 3 cosine theta. Not incorrect by having the 3 on the other side, just looks like it's part of the cosine. And then we add whatever the next product is. So negative sine theta times 4 would be what? Good. And since I'm adding, I can just simply say minus 4 sine theta, or you could say plus a negative. It doesn't really matter. We good so far? And then we would do 0 times 0, which would be, do I need to add 0? No, it's not going to change anything. You can if you like to, though. All right, so we good with that? All right, now we're going to take the second row and multiply this column. So what's sine theta times 3? Plus, what's 4 times cosine theta? plus what's 0 times 0? Awesome. Then we move on to the next part. 0 times 3. 0 times 4. 1 times 0. So what is this all going to be? 0. We good? All right. So now if we knew what theta was, we now knew its new location point. Now we can apply what we've been doing the last 2 days. And it's asking again, we're asking for this theta, but we're trying to put it out of sight on y equals 1. So what I'm trying to do is I'm trying to find some scalar in which I can multiply everything in order to get y equals to 1. All right. So therefore, what can I do to develop an equation? Good. I'm going to use this line right here to develop an equation. Now, when I do that, I get something like this. 3 sine theta plus 4 cosine theta times t equals 1. Now, notice I put all of that in parentheses. And the reason I'm doing that is if I actually knew what theta was, I would get a single number out of it, and then I would multiply that single number to the scalar. In this case, I don't have it, so I'm going to keep it in parentheses so I multiply the entire thing. So if I'm solving for t, what could I do? There you go. Don't try to distribute, just divide by this gigantic thing. So I'm going to divide this on both sides. So therefore, t then would equal 1 over 3 sine theta plus 4 cosine theta. So we all understand how that became my scalar. All right, ask the question. Oh, I just divided this entire thing. Since this entire thing is being multiplied to t, the opposite operation would be to divide the entire thing. So technically, this is what I did. I didn't write it out, but I did this. I divided both sides by 3 sine theta plus 4 cosine theta, which will just cancel that. And then on this side, I would now have the 3 sine theta plus 4 cosine theta, which is how I got to this point. Does that make more sense? Okay, so we're all good. Now I'm going to take this scalar and I'm going to actually multiply it to my coordinate to figure out what my value would be. So here we go. So 3 cosine theta minus 4 cosine, 4 sine theta, 3 sine theta plus 4 cosine theta, 0. This is just my coordinate. I now have my scalar, so now I'm going to multiply that scalar. So that's 1 over 3 sine theta plus 4 cosine theta. Before I move on any further, are we all understanding the setup here? And again, this will look a little bit easier and more familiar in the last 2 days if I just knew what theta was, because all of these will just be single numbers. But this is algebra or a pre-cal, so there's sometimes we just don't know the value yet. But we're good here. The process hasn't changed. It just looks different. It looks more complicated looking. All right. So then what I did is I multiplied that scalar to each one of my x, y, and z. So that's what I'm going to do here. I'm actually going to start z up because it actually becomes easier and then harder as we go. So what is 0 times this scalar? Awesome. That's an easy one. What would 3 sine theta plus 4 cosine theta times 1 over 3 sine theta plus 4 cosine theta be? 1. This guy and this guy would basically just cancel each other out because you're multiplying and dividing by the exact same thing. So I'm left with 1. And also, again, what we talked about yesterday, if I'm trying to get to this projection, then at least that's the one thing I know about the new coordinate, right? So I better equal the 1. Go ahead. So when I take the 3 sine theta plus 4 cosine theta, so let me put a little star here. I'm going to write a side note. You all see that blue on that black? Okay. So when I multiply this, I get 3 sine theta plus 4 cosine theta times 1, right? Because we multiply straight across. So I would get 3 sine theta plus 4 cosine theta And then technically this would be a number. I would put it over 1. And then I would do 1 times 3 sine theta plus 4 cosine theta. And then I would get this, which I can see this is the exact same thing over the exact same thing. So that would just become 1. We all good still? Next part's not as easy. I can't do any special canceling. None of them are really in common, so I have to write it out just like this. So this becomes 3 cosine theta minus 4 sine theta divided by 3 sine theta plus 4 cosine theta. That would be your answer if that was all that you were asked. If you were asked, do a rotation, project that point onto something else, that would be your answer. Done. To be honest with you, on the test, that's pretty much as far as you're going to have to go. But on this question, it has a little bit more of an ask. It's asking, what would that theta be so that all that I see is the y = 1 plane? So that means the only thing I want to see is a y = 1. I want the rest of it to zero out. So with that, I can take that x part and I can set it equal to 0. This is as far as you need to master. But of course, there's more to it as well. So I'm going to take this part right here, 3 cosine theta minus 4 sine theta over 3 sine theta plus 4 cosine theta. And I'm going to set it equal to 0. I want it to go out of sight. I only want that y = 1 to be the last thing remaining. When you look at something like this, what's your approach on solving it? When you're talking about a fraction, what makes a fraction equal to 0? You can multiply by the denominator, yes. And then what would happen to the denominator? It would go away. So I'm going to ask the question again. What makes a fraction equal to 0?
Multiplying.
What? Well, everything like that will multiply to 0. What makes a fraction equal to 0? Without multiplying anything. When you look at just a fraction, how do I know it's automatically 0? No. Not one of them. The numerator. A fraction is equal to 0 if the numerator, or the top part, is equal to 0. If the bottom part's equal to 0, can that be a fraction? It's undefined. So it has to specifically be that numerator part. So yes, I can multiply by the denominator to do the math, or I can use that fact that a numerator is going to have to equal 0 for the answer to equal 0. So I'm going to come over here, and I now have 3 cosine theta minus 4 sine theta equals 0. I can just drop the denominator if I know the fraction's equal to 0. We good so far? All right. So here we go. I'm going to add this 4 sine theta over to solve it. Mainly because I don't want to have to deal with negatives. Then that would give me 3 cosine theta equals 4 sine theta. We still go with this? All I did was just add that 4 sine over because I didn't want to deal with negatives. We good? I still have too many trig functions, and it doesn't really matter which one you divide by, but I'm going to go ahead and divide by 3 cosine theta. When I do that, what's 3 cosine theta divided by 3 cosine theta? Just 1. And then I get 4 divided by 3. We talked about this more in module 1, a little bit at the beginning of this module. But what do we know sine theta divided by cosine theta is equal to? Tangent. So I'm going to rewrite it. This is now 4/3 times tangent. You might not see it on my test, but it definitely could be on the final exam. We'll be on the test next week, but if you're taking the final, you're probably going to see this question. So hopefully you didn't just stop writing because you thought that's all you needed to know. But there'll be a recording as well. Well, it cancels, but it's like it cancels into one. It's like you got 3 cookies and you have 3 friends. So each friend gets what? 1 cookie. So it doesn't just cancel to 0 and you ate all the cookies and gave your friends none. You each get a cookie. So we're good here? Are we good? Again, the goal is to solve for theta. So now I got to get rid of this fraction. How do I get rid of a fraction, Jacob? He did say multiply by, you could, but I could do this all in one step. Huh? Not quite. We're not there yet. That'll be the next step. How do you get rid of a fraction? No. Multiply by what? What do you mean by opposite? Okay, that's called its reciprocal. Opposite would mean opposite sign. So do know the vocabulary there. That would be -4/3. That wouldn't help me anything. But you would multiply by the reciprocal. You could multiply by the denominator, but then you would then have to turn around and divide by the numerator. So it's easier just to multiply by the reciprocal. Now, when I do that to one side, I must do that to the other side. Now, what happens to this? What was the purpose of multiplying by the reciprocal? Now, I'm going to make it 0. To make it 1. That's why I'm able to cancel it and just write tangent, because what is 1 times tangent? Tangent. All right, that's why we multiply by the reciprocal. Go ahead. Sorry, that's in the equal sign. Yeah. So now we can do 3/4 times 1. Obviously, that's 3/4. All right, now we're getting closer to something we know. Now we can take the inverse tangent. So now I go and I write, this is now tan inverse of 3/4 equals my theta. Now we're ready to type it in the calculator. What's that give me? Make sure your calculator is in degree mode. $36.87 sounds great. We now have theta. To get rid of tan to find theta, I have to take the inverse of the other side. So again, at the very beginning of this problem, I could have simply said, rotate this point around z-axis at 36.87 degrees. I would then get some numbers. I would probably actually get 0, 4, 0, and then I would then multiply by a number to map on to y equals 1. That value would then end up being 1/4, and then I would just kind of go from there. Oh, I got you. Yes. So what I did is I then took this and did tan inverse, and then took this and did tan inverse. This part, it had to be somewhere at either the end of whenever we went over this, the first time you ever saw the unit circle. I think that was more in module 1 last semester. We talked about, now granted, we've been bringing that back up, but we've been so focused on just tangent that you might have forgotten the fact that, where is it at? Yeah, I probably don't have it written down anymore. Yeah, but that right there will probably be on your final. Ooh, I haven't done that yet. That would be then the next topic. Probably won't get to it as much as I would like to, but it's called cotangent. So tangent's just the change in y over the change in x. Cotangent is simply the change in x over the change in y. It's cotangent's like the reciprocal of tangent. It's called a reciprocal identity, actually. Because you have more than just, we know SOHCAHTOA. That's the part you're supposed to know is SOHCAHTOA. So sine, cosine, and tangent. There's 3 other trig functions. You might have noticed that when you hit the trig button, but you have secant, cosecant, and cotangent. Those are all reciprocals of the three original. Who? What happened? You can use your book on my final. You just can't use your notes and book on the EOY. But you can use this on the final. Any other questions? Huh? What? Logs? Oh, you did that in algebra too. 3/4 equals, that's an equal sign, sorry, theta, which theta then equaled 36.87 degrees.
You showed me what I did wrong.
Mhm. You're in radians. All you got to do is just hit it. Oh, and then come back over here. Just highlight it, enter,
Awesome.
bam, done.
Thanks, sir.
No problem. Yes. A what? Oh, yeah. I'm going to review everything we've done this semester for sure. Any other questions? All righty. I think I'm going to stop here in the recording because in lesson 27, we're just going to be analyzing this on that computer program. So you can kind of just watch, take some notes on it and stuff like that, but it won't quite be tested. You can, yeah. No, I have spaces for you to actually answer a couple of questions as you go. I would suggest at least do that because I might take it as a grade of just, did you do your notes for lesson 27? This test for these three topics, Tuesday, next week. A review on Monday. So if you're planning on not being here Monday,